Let's have a look at the proof of the polygon angle sum formula, which is angle sum equals number of sides times 180 minus 360. Another way this formula is written is the number of sides minus 2 times 180 degrees. So both formulas are identical, they're just two different forms, but they give you the same result. But I'm going to look at the formula in this way and in this form. Let's consider a pentagon. Okay, because we know the angle sum of a triangle is 180 degrees, so and that's already been proven using parallel lines. We looked at the angle sum of a quadrilateral, which is 360 degrees, and we thought about it as two triangles joined together. Each triangle is 180 degrees, and two triangles together form a quadrilateral, and we looked at that in a previous video. Let's have a look at a pentagon. So now we're moving to polygons of more than 4 sides. So let's consider a pentagon. So it doesn't have to be a regular pentagon. Any pentagon will do. Okay, certainly it's a 5-sided shape. And then what we're going to do is we're going to put a point in the middle. Okay, it doesn't matter where it is. All right, it can be here. And from this point, we're going to draw rays to each of the vertices. Okay, so you can probably see what we're about to do shortly. Okay, so I'm drawing really a set of triangles. Okay, so you can see that the number of triangles that I could break a pentagon up into, I could break it up into 5 triangles. In fact, I could break it up into 3 triangles if I really wanted to reduce the number of triangles. And if you wanted to see how that would work, let me just draw another pentagon. Okay, so this is another way that we could look at it. So I could maybe draw a line across that way and maybe down this way. So there's 2 different ways we can look at it. So I'm going to look at it using this first diagram. Okay, we could look at it using this diagram here, and in fact you'll get the same result. But just for now, let's look at it this way. Because I actually think that look, this may be an easier way to I guess to note the formula or to understand the formula, as opposed to just memorizing it. Why is the formula the way it is? Okay, so they've got 5 triangles. We know that the angle sum of a triangle, so in other words, if we added all 3 angles up, okay, of each of these triangles is 180 degrees. Okay, so let's note that. Okay, so okay, there's another one here and another one here. Okay, so we can see that all 5 triangles contribute, okay, of a pentagon, okay, is equal to 5 times 180. Okay, so that's the number of sides, 5-sided shape, multiplied by 180. But there's certain angles that don't count. And which angles do you think they are? When we're talking about the angle sum, we want the angle sum of the vertices, okay, of all the vertices. But the angles in the middle don't count because they're not at the vertices. So these angles here need to be taken away. Now recall the angle sum of angles at a point. Okay, so the sum of angles at a point, or angles in a revolution, equals 360 degrees, and that needs to be removed, okay, from this total here. So we need to subtract out 360 degrees. So that's where this 360 degrees comes from. That comes from a point somewhere in the middle of the pentagon where the angle sum of all the angles at that point is 360 degrees. And because those angles are not at the vertices, okay, of this polygon, we can't count these angles here. And it doesn't matter how many sides you have. We'll have a look at a hexagon in another video. Well, in fact, now let's look at maybe a side that has a polygon that has more sides than that. But you can see clearly here that we've got 5 triangles, 5 times 180 degrees. We take out the angle sum of the angles at a point in the middle because they don't count, and then we end up with this formula here. So 5 times 180 minus 360 is 540 degrees. Okay. and that is the angle sum of a pentagon. Okay, so this works for any polygon. Okay, so in another video, we'll look at a different type of polygon, and we'll see if the same thing holds true.